When molecules form, they do so in particular shapes based on this thing called VSEPR theory or the VSEPR model. VSEPR stands for valence shell electron pair repulsion. We know that electrons are negatively charged and therefore they repel each other. And so when molecules form, they form in shapes to minimize that repulsion. Remember, lone pairs are electrons, but bonds are electrons as well. So there's repulsion between lone pairs, and there's also repulsion between lone pairs and bonds. Don't worry about bond angles. They are given here, but you don't need to know them. So our first shape is linear. And there's two circumstances that will give you a linear molecule. The first is if it's binary, meaning if it's only made of two atoms. So if I have something like H2, it's just H, it has to be linear. 2 points make a line, right? There's no other option for that. If I have a triatomic molecule, so I have two atoms bonded to the central atom, and then this is the key right here, no lone pairs on that central atom. It's really just lone pairs on that central atom that's going to change a shape. So if there's no lone pairs on that central atom, it's going to be linear, because carbon dioxide is a really good example of this. When carbon dioxide is linear, those lone pairs on the oxygens are as far apart as possible. If carbon dioxide was any other shape, those lone pairs would be closer together. Bent is similar to linear, so we have two atoms bonded to the central atom, but there are two lone pairs. Or, I'm sorry, get rid of that word too. So we have two atoms bonded to the central atom, but there are lone pairs on that central atom. So something like water, we usually draw like this. And it looks like everything is, as far apart as possible, but it's actually not. What happens is those lone pairs, the electrons in the lone pairs end up repelling the electrons in the bond. And so the bonds end up on the bottom, on the opposite side, and the lone pairs are on the top. Something like ozone, this is ozone. Ozone does have resonance, but resonance does not affect shapes at all. Shapes are all about how many things are bonded to the central atom and lone pairs on that central atom. So something like ozone has that lone pair, so ozone will also be bent like that. Okay. Forgot that lone pair. If we have three things bonded to the central atom, that's going to be one of our trigonals, because tri, right, means three. So three atoms bonded to the central atom, and trigonal planar is a flat triangle. Plane is a flat thing, right? So a trigonal planar is a flat triangle. So there's three atoms bonded to the central atom, and there are no lone pairs on that central atom. So something like BH3 is going to be trigonal planar. We know that boron is satisfied with 6 electrons, so that's actually the structure for BH3 right there. But when it's drawn like that, that's not getting those electrons in those bonds as far apart as possible. And so what happens is they form this flat triangle, where if you were to connect those hydrogens on the outside, it is an equilateral triangle. So it's a flat equilateral triangle. They're as far apart as possible. Our other trigonal is trigonal pyramidal. So again, tri, so we have 3 atoms bonded to the central atom, but we have a lone pair on that central atom. So the difference between linear and bent is the same as the difference between trigonal planar and trigonal pyramidal. It's those lone pairs. Lone pairs will push bonds down. So ammonia usually gets drawn like that, but in actuality, that lone pair is going to repel those bonds, and so it doesn't form like that. It forms with the lone pair on one side and the bonds on the other side. And so it's not flat. It's kind of, if you look at the 3-dimensional picture, you can kind of see it's like a little tripod. It's got 3 little feet on the ground, and then that middle part is sticking up. Our last shape is tetrahedral. Tetra, of course, meaning 4. So tetrahedral has 4 atoms bonded to the central atom. Because we're not doing shapes with expanded octets, if there's 4 things bonded to the central atom, there's not going to be any lone pairs on that central atom, because there wouldn't be any space for it, because if there's 4 things bonded to that central atom, it has a complete octet. And so methane is an example of a tetrahedral, where in tetrahedral, it's a little hard to tell in the 3-dimensional picture, but it is perfectly symmetrical. If I was to flip that molecule around every single time, no matter which side I put it on, it's going to look exactly the same.